So, okay.
Good evening.
Howdy.
Welcome to the Astro Cafe for October 23rd of the 23rd year. So it's good to have everyone here. Tonight we've got I don't think we have a guest speaker, but we do have some of our own people who has a few things they want to talk about. So I know that John McDonald was on the list for, apparently he had a good time with his cohorts at Berwick. John, are you there?
I am. Yeah, can you hear me?
Yes, we hear you well.
Okay. So the first thing I want to do, I want to publicly thank Jeff Pivnick for getting some glasses to me before the eclipse, because there are 270 people living in this seniors place that I live in called Berwick Elk Lake. And they're not all interested in astronomy, but there's a fair number that are. And as a result of getting those glasses, quite a large number of them saw the eclipse through periods when the sun was cooperating and the clouds were cooperating to let us have a look at it. So thanks very much, Jeff. That was appreciated. The second thing that I want to say, if I can, is I want to just talk about NightWatch. Can you see that?
Yeah.
So a little bit of history. When I got started, or was thinking about getting started in astronomy, one of the first things I did was I bought a copy of the very first edition of Terence Dickinson's NightWatch. And the most recent edition is the 5th edition, which Terence Dickinson and Ken Hewitt-White put out together. And it's a beautiful recreation and upgrade of the original. And I was just thinking that with Christmas coming, some of you probably know somebody that's thinking about getting into astronomy. I can't think of a better book to get people started than that one. So I just wanted to mention that.
Hey, John, can you talk about the book at all? I've heard about it, but I've never actually looked at it.
Well, I guess the first thing I would say is that there is no other book that comes anywhere close to giving you a really clear idea of how to get started in astronomy, and gives you a whole lot of very good reasons for getting excited in it. It starts out with having, I think there are 10 or 11 pictures starting with the Earth and then going up by a factor of 100 times. And it does that 11 times until you're looking at the whole universe. And it just gives you an amazing idea of what it is you're starting to explore. Then it has chapters on picking a telescope and why you shouldn't do that first. A lot of the things that we tell people. It has sections on, equipment that you should think about that go with your telescope. And it's really well researched and well done. The advice is just first rate throughout. One of the new parts in it is there's quite a good section on astrophotography at the end of it, which pleases me. But it's just a very good all-round book, and it's in the bookstores now. I know I got this one as a gift from the authors because they asked me to use one of my pictures, and I said fine. But I checked in the bookstores and they have them. So NightWatch.
Talk about the middle section, John.
The middle section? What are you thinking, Lauri?
Well, the charts. And that's the best part.
Oh, the charts.
Yeah.
Yeah. The sky charts are exactly the right kind of sky charts to get you started for beginners. They're just absolutely gorgeous. There are charts like this. You see that okay?
Mhm.
There are really a large number of the kind of objects that you want to look at when you first get started on those charts. And it's organized in a nice way that you can find your way around the sky. For me, one of the big stumbling blocks to getting into astronomy was not quite knowing where to look. I don't know if you can see this all right, but they have charts side by side with a sort of a visual looking picture of it, and then a chart to go with it. And they're just so easy to decipher.
Yeah, that helps a lot because often
It's
you
a
have no
really
idea.
helpful thing, and it's at the right level for somebody that's fairly serious about getting into astronomy, but needs help. And the two places that I got help, first of all, it was from members of the Victoria RASC group, and I will always be grateful for that help. And this book, and I'll always be grateful for the help I got from them. So maybe that's enough to say about it. And I'm not on the payroll. Disclaimer.
Thanks, John. Appreciate that. So what were people's impression at Berwick? Like, were quite a few of them pretty impressed with what they were able to see? And
I don't think any of them had seen even a partial eclipse before. So they were very excited. They were very excited to see it. Most of them knew that it was likely to be cloudy, so they were not sure they would be able to see it, but I encouraged them to give it a try. And they did. Some of them tottered out with their walkers, and some of them stumbled out like me, and everybody that saw it got quite excited.
Good.
So there was a lot of talk around the place about it afterwards. And I think you saw, I took a few pictures just with an iPhone,
Mhm.
which I showed people, and they have a video that, or a television that shows pictures one after another, and they put those on there too.
Nice.
So it was good. It's the kind of thing that people here just really appreciate getting help with.
Thanks very much. So Randy, you've got someone sitting next to you there, Patrick.
Yes.
Um,
So I just met him 2 minutes before we started, and he has quite a history with the RASC and with amateur astronomy. So why don't you say a bit about what you've been doing?
Okay. Well, I guess since I can go back into the 2000s, I guess. I was on council with the Enkin Center, national council rep for a year or two. I actually had my own company with a partner, and we did astronomy outreach in Edmonton and the region for grade 4, 6, and 9s. I work in local government, and I've done that since 2007. And through that, I got a IDA designation for Bonnecourt, Alberta, first in Canada, and
That's
that's
the
the
IDA.
International Dark Sky Association.
Mhm.
And then I worked on the RASC designations with Elk Island and Jasper National Park when I was with RASC. And yeah, so the designation for Bonnecourt was first in Canada for an urban area and 11th in the world at the time. And designations now are popping up all over the place. But I think in Canada, it's still the only urban. There's a dark sky reserve through IDA in Quebec. But yeah, so I've also worked in tourism. So I worked in Hope, BC. I ran the visitor center there. And I helped Manning Park Resort start on an astronomy programming through their, like throughout the year. We held an astronomy weekend in 2018, and we sold out the resort in shoulder season, and sold out stays in Sunshine Village, Sunshine Valley, and a few rooms in Hope. But we had a really robust program, and we partnered with RASC Vancouver, and now the Chilliwack Public Libraries renting scopes in the valley, and etc. And then in Bonnecourt, I was working in Bonnecourt, and we hosted a annual, we called it the Equinox event, and we had up to 5,000 people every year into the community, 1,500 people. And in 2016, we had 2015 or 16, I can't remember. We had Chris Hatfield there at the event, and he was signing his new children's book at the time. And then I worked with Chris Hatfield again at a Canada Day event at the Edmonton Garrison. That's the first time I worked with him. And yeah, so I'm down here on the island now for my second year. I'm still doing economic development, but remotely for the Central Coast Regional District up in Bella Bella. It's kind of my story.
Well, welcome. And I
Welcome aboard.
hope you find this community entertaining.
Awesome.
You do.
Hey, buddy.
Oh.
Know him well from Edmonton.
To Edmonton.
Put up your hand if you have an Edmonton connection.
They've all shows pictures from Edmonton here.
Yeah, I did lots of good work out in Bonnecourt, that's for sure.
Cool.
Yeah.
Apparently Jeff had something that he wanted to speak to. I assume that's Jeff Pivnick. You're muted, Jeff.
There we go.
Yay.
Yeah. Thanks. This was, I was hosting Astro Cafe last week. And with some of the reading I did, there were a couple of things that came up because we got involved with the eclipse quite rightly. There were a couple items that I wanted to mention, but we didn't get a chance to delve into. So a little bit brief, but I just wanted to talk to you about this. I found it fascinating. I'm just going to pull the slide up on the screen. And I'll walk you into this. So I did the cafe on October the 16th last week. And as it turned out, October the 16th, 2023 was the 6th anniversary of the first witnessed neutron star collision that occurred in the southern hemisphere in the constellation Hydra. The interesting thing about that, and why astronomers were interested in identifying that and watching it, was because of the hypothesized nature of the interaction, thought to create some of the heavier elements in the periodic table. It was a hypothesis at this point, but nobody really was sure. So I'll try to walk you into that. But firstly, this slide, it comes from the NASA website. It was used as a NASA picture of the day in January of this year, of 2023. But it actually was created by an astronomer at Ohio State University, a gal by the name of Jennifer Johnston. So it's got an interesting origin. Jennifer works actually on elemental evolution or origins. So originally, thinking about the elements that make up the periodic table, hydrogen and helium are thought to have occurred in the Big Bang. It's found throughout the universe and in quite a bit of abundance compared to the other elements. When they looked at the other elements, it was thought originally that a lot of the elements resulted from fusion in the centers and the cores of stars. But as physics and astrophysics went along, it was realized that the elements up until an atomic number of 26, that is iron, probably can occur naturally with fusion in the core of of many stars. But beyond that, because the process to create the element is a little bit different, the normal stars that we find just aren't energetic enough to create the elements. The process is called neutron capture, where neutrons are actually added to the nucleus of the atom, and then degenerates a little bit to create a positive charge, to create a proton. So that was thought to be how the elements were built. But you know, until they could identify it specifically, it was just a hypothesis. Around waiting for this, 6 years ago, they were able to witness the explosion or the interaction of two neutron stars. It's called a kilonova, different than a supernova and different than a nova. So thought to generate intermediate energy. In fact, so when they witnessed it, they first identified strontium, which is atomic number 38, and then subsequently they were able to identify, as they expected, the heavier elements. Two of the articles I read jumped up and down about it being gold, but I think that was for public consumption. Subsequent work showed it generating a number of the heavier elements, and you can see from this periodic, which is more recent, that it's thought to be, it's the neutron star origin is the purple, so it's thought to be a number of the heavier elements. So that was really the what I wanted to bring to your attention. Now, some of you may have actually spent a lot of your academic life dealing with this kind of stuff. So if there's anything to add or correct, greatly appreciated. It seems very interesting.
Jeff, it's interesting that beryllium and boron are both cosmic ray fusion. Do you know what, or fission? Do you know what the fission starting element was? Like, because it must have been one of the higher mass elements. So it's odd that those two are just out on their own there.
It was interesting. I didn't find that, Brock. Okay. But it is obviously because those two are from fission, or thought to be from fission.
Some of the elements are not long-lived, so they will decay. So you'll get, because there's various isotopes in the element, and so they will decay, and you get growth and decay happening at the same time. Based on their stability. But iron is the lowest energy of all the atomic nuclei. So that's why all fusion gives off energy, like a star giving off energy, as all the lighter elements end up in iron. But when you go past iron, it requires energy. It becomes endothermic. Fusion becomes endothermic. And fission, breaking apart, gives off energy. That's why uranium fission gives us, we can make electricity from it. And that iron is that low point. Just to add my chemistry background.
Jeff?
You know specifically then why beryllium and boron would be identified as resulting from fission, but the rest from other processes?
Well, you have to look at the process that creates those. Like it probably creates something heavier with an unstable isotope then that undergoes fission and creates those.
Mm-hmm.
Jeff?
That's a good question.
The exploding massive star, that's the supernova. But it seems to stop at what, about 40 at zircon. Is it no longer considered to be where most of the heavy elements come from? The supernova's day over?
I thought that was very interesting also. No, it wasn't. And you know, when I was thinking about it and reading about it, I'm assuming it's because the neutron capture is a quantum event. So that the supernova is presumably too energetic to create some of the heavier elements requiring the neutron capture. But and I think that's why the kilonova was hypothesized as being probably the event that would create the right amount of energy. It's less energetic than a supernova, but more energetic than a nova.
Interesting.
Jeff, I have a question. There are some elements down near the bottom. There's francium, radium, actinium, so that are a different color than anything showing up above. What is the process for that they're saying now for those?
There wasn't a legend for that, and I assumed it was ones that they just weren't sure what.
Oh, okay, yeah.
Well, aren't those the human synthesized
Yeah,
ones?
some of them are not
Yeah.
naturally occurring.
Yeah.
I
think
can
some, but
certainly
some are.
confirm that this is a very different picture than what I learned when I was a graduate student. But
Mhm.
the kilonova data has really changed everything, I think.
Mhm.
Interesting.
And the other point, John, I think that the human synthesized are heavier than 94, because I think we're up to about 100 and.
Okay, yes.
Yeah.
Except for 43, technetium.
Okay,
Leslie has a question in the back here.
Yeah,
yeah,
Hi, I came in late, so maybe I missed this, but how is it that dying low mass stars create all those higher atomic number elements?
so.
Yeah, we just-
Yeah, so this comes from Jennifer Johnston's paper. The chart is just one of the things in the paper. And I had assumed that it was just, again, the quantum energy with each of the different with the energy generated by the different phenomena that were responsible for the different elements being created.
it's the energy of the supernova or the energy of the two neutron stars supplies that energy to make
Dying low mass stars?
The green ones.
the green ones.
They would just be novas, wouldn't they?
They would just be novas, yeah.
Well, then it wouldn't be the dying low mass star that's creating the elements, it would be the
Yeah.
nova. But that doesn't seem likely either, because all of those elements are quite high atomic numbers, so they need to be created,
Yeah, I wouldn't
I
think
thought,
that's-
in supernova.
Yeah.
Yeah, and it seemed not to be the case. And the other interesting thing is, you know, as you point to the dying low mass, you know, the dying low mass also seems to be many of them also attributed to the emerging neutron stars. So whether it's both or whether they're not certain which of the two, or whether, you know, the amount of the coloring you know, differentiates, you know, how much they think it's contributed. But it's a very good question.
It's a really good periodic table, though. I've never seen this depiction before. This is quite interesting.
Yeah, for sure.
But whether low means low for creation of a black hole, or low means low, what does low mean?
In terms of
Yeah.
low mass.
The mass is not great enough to create a supernova.
Right.
Mhm.
That seems very
Interesting.
possible.
So it wouldn't be creation of a neutron star.
So this would be material thrown off in a planetary nebula in the surrounding gas and dust potentially, or would it be stuff that's left behind?
But that would be exploding white dwarf, right? So
Yeah.
I'm not sure what they mean. A brown star or?
Are they suggesting maybe it just accumulates or something and then eventually it disperses from there? I don't know.
Mhm.
Interesting to read and see if that's mentioned as to what it actually means.
Yeah, it's an interesting chart.
If anybody's interested, I can post the the reference for her article. I can put that in the sidebar.
Yes, please.
Please do.
Yeah,
Right.
no, no, good to do that.
Helium, lithium, and then the metals.
Yeah, that's one view.
Cool.
Lauri has a question.
Oh, Lauri, go ahead.
Yes, I was just looking. Lithium is the only one that has 3 colors. So can be made in a variety of ways, which is interesting. I mean, it's so low in, number of protons and electrons. That's real. It's just interesting that just right after hydrogen, but kind of in between the fission and the fusion. It's kind of cool. That's all.
Well, there was some created at the Big Bang, right? So it's all hydrogen, helium, and a little bit of it.
Helium is done 3 ways too.
Yeah, I can't
Oh,
see
sorry.
helium
My
because of the sidebar.
Yeah, it's close.
my helium is
There's
another
wrecked.
good.
Yeah, sorry.
Yeah.
I'm only
Sorry
looking
about
at
that.
lithium there. Okay. It was just an interesting
Yeah.
thing. Thank you.
Mhm.
Good chart there, Jeff. Thanks.
Yeah,
Yeah, no, it's interesting. Okay, and I will put that reference in the side note in the discussion.
thank you.
I will give you the screen back, Rob. There you
Okay. The people I had listed there, is there anyone else that had anything to speak of?
Well, I've got Eclipse stuff. And
You've
then
got
there's
Eclipse
talk about Planetary Nebula party.
Yeah, well, I was hoping to segue from the creation of all of those elements to the actual things that did them.
Ooh,
Ooh,
you're
nice.
classy.
Oh, well. Dave, have you managed to queue up some images?
Sure. Are we interested in planetary nebula?
Yeah, we could do that. Pick a
Nine
theme.
stars?
Otherwise, we've got so many pictures, it's hard to narrow it down.
Well, I've got some interesting ones. I did go on a bit of a kick, so I gotta share it.
Can you hear Dave?
Yes. It's a bit quiet because he's further out, but
Okay, I'll speak up. I just gotta share my screen here. Okay. So this is actually just before a star is going nova. So this is just before the creation of the planetary nova. It's actually a very much enlarged image. So I've really zoomed in a lot. I don't think I have on here, but the original image, but you can imagine the entire frame of the camera is about 10 of these wide and 10 high. But you can just see 2 jets coming off of the central star of material starting to come out. And this is a protoplanetary nebula, so there's a few of them. Feel weird, put me onto this one. And then I'm going to.
Can we talk about this one before you go on to the next one?
Sure.
This is very interesting because you're saying it's just as the star is going nova. But
It's a protoplanetary nebula.
okay, but stars go nova or supernova from the inside out. They don't start with jets coming out the sides.
Well, they
They-
before they expand.
Okay, so
So
it's really started to go nova. I
yes,
guess
it's
a
just before it's going nova, I guess.
or just as it's going.
Yeah,
Okay,
and I guess they figure.
so
In
this
some
could last
times,
thousands of years or maybe 1 million or 2 years.
yeah, it would be a fairly short period of time. I don't know. I can't really say.
Okay,
So that'd be a good lead in. So, along with planetary nebula, some are questioned as to whether they're actually planetary nebula, and some are supernova remnants. Sometimes it's questionable. Generally, you can tell from the size. But here's a very, very dim planetary nebula, a fairly large one. They seem to come in a variety of shapes and flavors. A lot of them are showing either O3 emissions or hydrogen alpha emissions. And so you see a lot of them are red and a green blue as they use with narrowband filters. Here's one that's described as the most spherical object out there. It is a nice spherical planetary nebula, and there's actually a little galaxy right here that you can actually see through the planetary nebula.
Not inside.
Yeah, not inside.
How do you know what's swimming around in there?
And then
That's wild.
some of them, there's one here. This one, right in the middle, it's undergone two sort of expansions and two sort of throwing off its gases. And it's actually called the born again planetary nebula because it's basically gone off twice. It's quite interesting. This one happens to be smack dab in the middle of a nice blue star and a nice red star. So
Yeah.
some natural framing that's going on there. But a lot of them kind of look like this. They kind of look like a barrel shape. And you've got this hydrogen alpha, and you're looking down through the barrel, if it were. You can sometimes, depending on the size, you can see the white dwarf. That this one happens to be right in the middle there. But you often get this with the most famous one would be the Eclipse Nebula, which is quite a bit larger, but you can see it kind of has the same structure.
Mm-hmm.
Then you get ones that you either say it's actually a planetary nebula in a windstorm, or the planetary nebula is moving through the interstellar medium. So it's actually creates sort of a wind, and you can see this. The wind here is coming from the left-hand side, it's blowing the outer shell, which is getting dispersed over here into the interstellar media out here.
So would that barrel shape be because most of the eject is coming around the equator of a rotating star, as opposed to just a spherical?
Yeah, you can see the.
Could you hear the question?
Not really clearly, no.
Now, I was asking if the barrel shape is due to most of the ejecta coming off of around the equator of an exploding star, rather
Oh,
than
right.
exploding.
Well, some of them are spherical.
Yeah, some
indeed.
are, yeah.
And some of them seem to have that two-dimensional, rather than a three-dimensional symmetry to them. I don't know if it is just like asymmetry in the way that the stars collapse or what. I really don't know the answer to that. But it's like, I mean, this year, planetary nebula has been my little fashion that I've been going after. But it's just remarkable the varieties that they come.
I never did.
Here's another one. This is a narrowband image, but this one's moving through space too, or there's a wind against it. And you see the gases in the upper left are being compressed. We got the white dwarf in the middle pushing it this way, and you got the winds coming against it from this side, and so compresses and forms all these nice little filaments on this side. And then on the leeward side, it's just getting interspersed in the interstellar medium. So it's quite fascinating because you can't actually see the interstellar medium. You can see through it, but it's there. It's not empty space.
Do you know which star is the white dwarf there, Dave?
Yeah. It's just how different they all are. They're not great in terms of the future of the Earth, but once you look past them. This one was, I'll finish off with this one. This one was debated. It was actually discovered in the 50s. It's very, very faint. And it was debated and is still debated. It was listed as a planetary nebula. I think it is a planetary nebula in a windstorm, but some people disagree. And there's a question, there is a white dwarf star in there. And people say, well, that conclusively tells you there's a planetary nebula, but there's still a question about whether that's so. So that's probably plenty of images for.
That's
Great,
fantastic.
Beautiful images, Dave.
Traveling planet.
Wow.
The traveling planetary, leaving stuff behind it.
I've got one concern. The rate at which you're taking these planetary nebulas, you're gonna run out of planetary nebula targets in 3 years, I think.
You have a point,
There are
Rich.
lots of them out there, and as a reflection of the summer weather, I am slowing down now.
But there's only about 1,500 that are there not, because they've got a very short lifetime and they have to be fairly close to us to see. So
Okay.
well, maybe you're doing the service capturing them so quickly.
Well, this would be about 3 nights.
Well, we want you to take longer and make a motion picture out of it.
Yeah. Lauri, did you have a question?
Yes, I was just going to suggest we have got some lovely display boards at the center that haven't had anything on them for a while, and wouldn't these be just absolutely fabulous? To be printed out and with an explanation beside them and for more people to see. They're absolutely beautiful, David.
Oh, thank you, Lauri. I will work on that.
Okay.
I think we have a budget for you for that.
Well,
Yeah, well, or any of the other people that have got pictures. We've got room for, at least 12, maybe 24 really nice pictures to go up there that, could be displayed for everybody to see. So it would be great. Thank you.
I think David Lee was involved in a project to do just that, but we rated his valuable time to do so many other things.
Yeah, I think it probably needs a refresh now. I think the original display project kind of morphed into kind of a video thing, which was kind of more in line with the pandemic. But yeah, I mean, there's been such tremendous work going on over the last couple of years that it would require a refresh. I think that's a great idea, Lauri. It's now that we have some venues, we can put them out there.
Thanks.
So
Nice.
I got a question, Dave. Has there been enough time since the first pictures of planetary nebula for there to be any observed differences over the time that they've been observed? Or is it,
I don't think so.
they appear to be static on human timescales?
Yeah, from the pictures I've seen.
Okay.
Well, there's an exception to that.
Yeah, there's actually is. Sorry, go ahead. Who is that? Gary?
Yeah, it's Gary. The Crab Nebula has a very nice movie showing all the filaments inside of it moving.
Yes, and expanding.
And expanding, yes.
And
There you go. So that's a supernova run.
Over the time that I've observed the crab, it's changed a lot
Really?
in the last 20
Like,
years.
you could tell just
Oh, yeah, it's quite obvious.
with,
Yeah.
It has a pulsing neutron star in the middle, and you can actually see the star pulsing.
It literally swirl. You can see the swirling motion in this. The guy did a time lapse, and it's pretty amazing. But that's also, there's another supernova remnant, of course, the Veil Nebula. The Hubble telescope has measured quite an expansion since it first went up and photographed that as well, and it's quite but again, that's not a planetary nebula. But
Is the Crowd Nebula a planetary nebula per se?
Supernova remnant.
it's a supernova remnant. Yeah. So I actually have some other planetary nebula too here, so I'll share those.
56?
Yeah, it's very recent.
Oh, okay. That's one in the Concord time.
Yeah. Pretended before.
Can you guys see that?
Beautiful.
Messier 57, another planetary, and of course it's got a white dwarf in the center, and there's a little galaxy sneaking in and photobombing it. And then there's a much larger and much closer, very similar looking planetary nebula, which of course is the Helix Nebula. And it's obviously a lot more impressive because of how close and large it is. You can see a lot more of the detail, but it really shows well the white dwarf in the center, and you can really see a lot of the texture of the way things have gotten blown outward. And then this one is the Owl Nebula, which again, there's a visible white dwarf in the center of that. It's a little bit harder to see, but zoom in and
It's almost like it's out of focus, that one, right?
yeah, it's a weird one. Even if Hubble does a picture of it, it looks out of focus.
Yeah.
Mine is genuinely out of focus, I'm sure, but
No cheating.
Brock,
Yes.
there's a small kind of a red artifact around 4 or 5 o'clock. Do you know what that is?
Well, it would be, I mean, this is primarily oxygen emissions on this particular planetary nebula. This isn't in any anything other than essentially quote unquote a true color palette. So the red would represent hydrogen emissions. But
Okay.
clearly in this one, unlike something like the Helix, which is very dominantly hydrogen with oxygen more in the center, the Owl Nebula for some reason is much more heavily dominated with oxygen emissions. So whether that just happens to be that the star's composition or the hydrogen got blown out further and the energy hasn't gotten there, or I don't know, but for some reason.
Is this dual band or is it narrow?
This is good question. It's probably my dual narrowband, but I
So
don't have it.
oxygen and H alpha then.
Yeah.
No, good, very nice.
And then this one is the Little Dumbbell Nebula, which is again a little planetary nebula, but it's probably quite large actually, but little in the sky and quite faint. But it has another nice mix of the oxygen, the greenish turquoise oxygen, and the red hydrogen emissions. And it's kind of got two lobes to it. So I don't know exactly the mechanism there. I don't know if Dave Payne's looked into it, but there's something about whether that's due to the spin that's present when they first start to expand, or some magnetic fields, or a bit of both. I'm not sure.
It's got a bit of a soft ice cream twirl at the top.
Yes. Yeah. Interesting texture. And then there's the Big Dumbbell Nebula. Well, it's just called the Dumbbell, but anyways, I don't know if it's bigger but it's definitely a lot closer. And
yeah, this one's M27, isn't it?
Yes, it is.
Yeah.
SA27.
Yeah, I've always been impressed by this one because this one has kind of like angel wings, where a lot of them, when you see them, they're more like just the apple core.
Yeah. Yeah. Yeah, there's an amazing amount of texture and sort of billowing. Looks almost like it's like a smoke ring or something, the way that these textures areas are. So be fascinating to know a little bit more about the mechanisms there and what creates the kind of the X pattern. And again, I don't know if it's some sort of the rotation or magnetic fields, and who knows.
Yeah,
Then-
that's right, Brock. I mean, a lot of these, we're viewing them from a particular perspective, right? If we were able
Yes.
to see them from a different perspective, they probably would have a different shape.
Absolutely. And then, of course, the Crescent Nebula, which is another planetary nebula, which is around a Wolf-Rayet star. And then there's always the Crescent Nebula smudge, which everybody who's ever photographs it thinks is some problem in their image, but there's a black spot there. And at first you think you must have some grit or something on your camera lens, but then you look at every other picture that's ever been taken of it, and it all seems to be there. So and it again is quite a combination of the hydrogen and the oxygen emissions. And then I also have this, I don't know if it's technically a planetary nebula, but this is the Soap Bubble Nebula. And it's, I believe it, I don't know, Dave, do you know if that's truly a planetary nebula or if it's just a young star with its solar wind creating a bubble? It's anyone's guess. But
On Dave, you're supposed to know these things. So I learned something tonight, that a supernova remnant contains a black hole or a neutron star, while a planetary nebula contains a white dwarf. Well, there you go.
yes,
Right on.
cool. And that's all of my planetary nebula photos.
Very nice. Very nice, bro.
Thanks. So I don't have anything else on the docket for people that wanted to speak. Is there any thing? Lauri probably has a few
Andy,
announcements.
Yeah, there's a
And
couple
I
of SIGs. There's a couple of SIGs this week as well.
Okay.
But I'll let Lauri go first.
Yeah, sure. We'll get
I
on
was
to
just going to say, you'll be just thrilled to know that I have the calendars in my possession in October of the year before they come out. So they have come, and I've got a list of people that wanted them. I now need to figure out how to get them to everybody. I think I figured out that I think we're still going to just do $15 for them. I think they end up being maybe 60 or 75 cents or something, a little bit more than that, but I guess it's not worth trying to get an extra 65 or 75 cents out of people. So we'll just keep it at the $15. I don't have the other almanacs and the other ones that have been ordered yet. They're still to come. So I'm still taking orders for the calendars. I have not completely sold out of them. So if anybody would like a calendar, please just put it in the chat or email me directly, and I'll get them out to you. Maybe one of the nights I can get down to the Astro Cafe and give out some of them right at the Astro Cafe. Maybe try to get them down in, and again kind of hand them to various people so people can pick them up. Because it takes about 2 days to go to everybody's house to do all that traveling in about 400 kilometers. So I'd rather kind of do a little bit more of a kind of a central depot type of thing. So we'll work that out and get it out to everybody. But please put down, if you still want a calendar, please let me know.
Thanks, Lauri.
Thank you. And just thanks to everybody that came out to our annual general meeting for the FDAO last I guess 2 nights ago, and to people who came up and helped. Again, Ken Mallory, just absolutely amazing, came up and he actually had his telescope out and was showing people just through the little bits of the things, the moon, because it was International Observe the Moon Night on Saturday as well. And so we were able to see a little bit of that. And James DeFrancesco gave a terrific presentation on what's happening with the new square kilometer array that Canada is now involved in. And I mean, it's like, absolutely, we are now committed to it, both in Australia and down in South Africa. And he gave a really good presentation on what was happening with that. So may want to pull him into to a presentation sometime, because there weren't quite, not, I mean, obviously not everybody that's on the call here tonight was at the meeting. So, all right, that's all I have for now.
Thanks, Lauri. And David, you can
Yeah,
speak
just a
about the
couple of
SIGs.
quick comments. I think Dave has already sent out the notice for the astrophoto SIG, which is this Wednesday. But the other one is we shifted the makers group to this Thursday. I don't know if we have a lot to talk about, but I've been working on a few mods to my equipment. I could probably talk a little bit about that. And I noticed that Jim's been doing a lot of kind of radio stuff. So I'm hoping that he might be able to tell us a little bit about that for anybody who's kind of interested in the relationship between radio and astronomy. I think he was doing a couple of things in the last couple of months that I've seen him involved in. If anybody has any questions, the makers group is kind of a hodgepodge of different things. We often kind of work on other people's problems too. So if you actually have a particular problem with your gear right now, come to the makers group and we'll kind of put our heads together. And by the way, Lauri, I guess we might as well put a plug in for the November Star Party, because we're going to have kind of like a fix-it kind of clinic in November, where people can just bring their telescopes that are not functioning, and we're hopefully going to make them function. And or people that just don't know how to use them because they've been sitting in the closet too long. But I know that Brock's going to come and help, and Bill Weir, who is our official medic, telescope medic, is going to be there, and I'll be there. I'll help wherever I can. So yeah, so that's coming up. And if you have any special requests, let us know ahead of time, just in case we might have to kind of prepare for that.
I think that's November the 18th. Thank you. I don't have the calendar sitting in front of me. The Saturday, November the 18th. Yeah, so everybody's invited to come up. So
how can we get an invitation to the makers meeting?
You send me an email and I'll send you the link. I might for this go around just send it to RASC. I mean, just in case people don't know what it's about, you can certainly just kind of drop in and see what it's about.
Cool.
But if you know you're a maker and you know that you're working on things, send me your email. Send it to my David at victoria.rasc.ca email, and I'll add you to the list.
So is the makers SIG akin or similar to the creators SIG?
Creators SIG. There's no creators SIG. There's a citizen science SIG. And that's tends to be a little bit different. But the makers group is just people that like to tinker with their gear, or they have broken things that they like to fix, or people are kind of rolling their own kind of stuff. I know Brock does this all the time. He's always making little things that are useful, and I'm always dabbling in electronics and not getting very far, but I'm having fun kind of trying to do it. I've got a few mods that I've done to my tripod that I just got some parts recently, so I can probably share that. And also share a little bit about the strain wave mount that I've been using lately. So little things like that. If there's some new technology, a lot of us probably kind of dive in and try different things. So if you're interested in different kinds of technology, it's a good group to join as well.
There's someone in our RASC that just got a new 3D printer. So
Oh, that's kind of cool. Who's that? You?
no, not me. I'm not volunteering him to build stuff for people, so I won't. mention
Oh,
it.
okay.
You're gonna be printing Planetary Nebula?
I don't
Wouldn't
know
that
where
be
you
cool?
I don't know where you get the files for them, but
Yeah.
you'll have to imagine the other perspectives, I guess.
Cool.
Great, thanks.
Well, actually, I have, this is,
Oh
this
yeah,
is
right.
Etta Karina.
Oh,
Oh, that's
And-
3D.
And one of the guys I was working with on the Hubble book was really into Etta Karina, and he made these things, and he loaded the file onto some thing where people with 3D printers can find stuff.
Maybe Thingiverse or something.
So I talked Joel into making this for me a few years ago.
Okay.
So there are
Nice.
things like this around.
Well, the classic thing would be like lunar surface, like craters and things like that. That would be kind of cool.
I have a
Yeah.
3D printed moon puzzle. It's like
Well, there you go.
500 pieces that makes the moon, and it's wonderful. It's in my dining room.
I'll tell you that the Carina Nebula to the eye in a telescope doesn't look that good. It's a lot more wispy.
Yeah, but this is a guy who's dealing with Hubble all the time, and so he has high standards.
So Randy, where on earth did you get your 3D moon puzzle from?
Okay, my son commissioned the father of a friend of his to print it, and I can get the information on it, but it's not really a puzzle because you wouldn't want to do it without the guide. So it's actually it's
a model.
It's a model, but I'm thinking it's a geodesic dome. So is it 5 times 20? It's probably 100 pieces.
So Randy,
I
are you
would
saying that you cheated?
No, I am saying that I put it together following the directions, like a model.
Okay.
It's a model. Yeah.
Randy, is
Nice.
it like this?
Yeah.
Randy, is it like that?
Yep.
oh wow.
That's it.
Okay, well there's the URL to the STL file.
Anyway, it arrived in I guess 3 or 4 sheets, each with many puzzle pieces on it. Anyway, it was very fun putting it together.
Isn't that a picture of the Death Star after it exploded?
There's a place called the Thingiverse, and if you go to the Thingiverse, it's full of different models. Some of them are space models.
Well, you certainly can just Google that or just search inside of Thingiverse, and there's lots of STLs there, like STL files.
Well, Mimas is the Death Star, of course, so not our moon.
Well,
Chris, is there any more James Webb news?
Not that I've heard, really.
Okay.
Brock,
Yes,
can I take the floor a bit?
absolutely.
So one thing is, I love the conversation and all the different views, and this is something Chris was wanting to bring up. Now that we have our monthly meetings at the university with the more organized or what shall we say, formal presentations, he was saying, and I totally agree, that we're hoping for more of this sort of stuff that we're getting tonight at the at the Astro Cafe. So little talks that we are giving among ourselves and showing off pictures and talking about the research that people within our community are doing. And then we won't have as often an invited speaker, with the exception that people who are coming from far away on Zoom, then probably the Astro Cafe is the correct forum rather than to project a talk at the university.
I think we'd have trouble with interaction at the university. I don't think they'd be able to hear us.
Okay.
So I think we'd be basically projecting a person on the screen and we'd hear them, but not the other way around.
Anyway, I have to say that this is what I dream about for the Astro Cafe, where there's lots of interaction. Anyway, I would, if I have the floor, like to give a couple more of my vignettes from the eclipse. So what Lauri had me do was do 5 short talks, which I did every 15 minutes except around maximum. And so I'm going to right now talk about the some famous eclipses in history. And so there's a fair bit of discussion about what is the first eclipse that we actually have the date of. And some people have quite credibly said it's from this book in the from the Zhou dynasty, but that would put it down to more than 1000 BCE. There was a discussion of a lunar eclipse. But there were a couple in the next millennium. One I didn't prepare a slide for was, I think, 585, something like that. There was a great war in what is now Turkey. And when the sun disappeared, then both sides just put their arms down and ran away. And then this one in 413 BC, it was when Syracuse, so from Sicily, was attacking Athens, and there was a lunar eclipse, and the leader of the Syracusans got really scared and then decided to attack a month later. And that was really bad because that gave Athens time to rearm, and they broke out of their siege. One of the most famous. Okay, so there's a way that we can get rid of the thing at the bottom, Chris. Do you know what that is?
We have to get rid of whatever's on that far end there. The more. See, there's something down at the more. There's a number. You gotta hover over it.
Anyway,
Where? There, the bottom right.
Christopher Columbus had a handy dandy table of eclipses in his almanac that he had in 1504, which kind of impresses me. But he knew that there would be a lunar eclipse. Now, this was his last trip, whether it was his 4th trip to the Americas, and he was hanging out in Jamaica, and they were equipping, feeding and providing for Columbus and his crew, but they were starting to grumble a bit. And so, in a way which was quite dishonest, but he said, if you don't feed my crew, I'm going to make the moon disappear. And he had the right information, and he scared them, and then they got, he commanded a lot of respect from them again. And so after filibustering until they agreed to feed him, then the light came back to the moon, and
What a jerk.
I know, no, but it was,
Colonial intimidation.
but you get this sort of story lots in literature. So like there was the Connecticut Yankee in King Arthur's Court where that was part of the story, or here it is in Tintin, where the wily colonist knows when the eclipse is going to come and scares the people into getting what they want. The eclipses that I really like are the ones that are important for their scientific purpose. And one that I don't illustrate was in the 5th century BC. What was his name? Aristophanes figured that since he understood that the lunar eclipse, you saw the limb of the Earth, and he knew how big the Earth was from the looking at the shadows in the wells in Egypt. That's a whole other story. But he knew that what the size of the Earth was, and by looking at its projection on the moon and knowing how fast the moon, the moon takes 29.5 days to go around the Earth, he could then work out how many radii away the moon was, and he got it spot on, like to within better than a radius of the Earth. But one of the best stories was 1868. This fellow Johnston was looking at the spectra of everything he could see, and had the clever idea of looking at the corona during an eclipse, and there was this really strong emission line in the yellow. And at first he thought it was sodium. Sodium lights are very yellow. They have that. Actually, there's a pair of emission lines in sodium. But by careful measurement, he said, no, I've never seen this in anything that we've put in flames. It's got to be a new element. And because helios is the Greek word for sun, he called it helium. And it took another 17 years till it was discovered on Earth, which I think is very courageous for a scientist to make an observation and say, I have understood something nobody else has understood. I love that. That's part of what makes science very exciting. But that was a beautiful observation directly because of an eclipse. But then the most famous eclipse, at least I would say, was in 1919. So remember that in 1916, Einstein published a very important paper on what he called general relativity. But the relativity that he was talking about was how you cannot tell the difference between acceleration and gravity. There's no experiment. If you're in an enclosed elevator, you wouldn't be able to tell if the elevator is actually accelerating up or if you're in the gravitational field of the Earth. And he says there are no coincidences. I don't believe in coincidences, so that inertial and gravity mass are indistinguishable means they've got to be the same thing. And from that came a whole bunch of mathematics, but among the things that he hypothesized is that you should be able to see the deflection of light around massive bodies. But the problem is you can't see stars close to the sun, except on those occasions when the moon gets in the way. And so they figured out that the Hyades cluster was going to be behind the sun if you went to Brazil in the eclipse of 1919. And Sir Arthur Eddington went down there, pretty gutsy. You know that it's going to be cloudy, or you have a good chance of it being cloudy, but he set up is he set up his observatory, took pictures of the Hyades to make sure with this particular camera, this is how they would look, and then took the picture of the Hyades during the eclipse. And this is a doctored up picture because the original picture, and the way I've seen it, is pretty hard to see. But what you see is the closer you get to the sun, the more the deflection. So the red dots are after the light has been deflected, so that because we think that the light is going straight, you would see the star further away from the sun, depending on how close you are. So if you're closer to the sun, it is more deflected away from the sun.
Gary has a question.
Gary,
Yeah, I don't get that. I would have thought it would have been the other way around.
good. So let's talk about that again. If I am looking at, so I'm here, I'm where I am right now, and I'm looking at the direction of the yellow. So that's where I was going to expect it. But actually, if I do that, that's going to be deflected more behind the sun. So in order to direct my telescope or my line of sight towards where that yellow point is, I have to go further away, and then it curves back. It's getting curved in towards the yellow point. Does that make sense?
No,
Oh,
I
God.
believe you when millions wouldn't.
I think I need to do a diagram on the whiteboard. I don't have a whiteboard here.
Oh, yeah, draw a picture looking down on the sun and the starlight coming around it. That would be great someday.
Anyway, that was that talk, and I'm going to do a really quick talk just for fun. But as some of you know, I post a picture of the moon every day on Enkin's Daily Moon, and several of them feature eclipses because I love eclipses. So
Is that your sketch?
no, that would be really no. I only do black and white sketches of the moon. So that one's clearly not mine. So this is an old textbook. I didn't put the captions in, so we're just going to look at how pretty these pictures are. This is Harrison. What's his name? Ted Harrison.
Yeah.
So in 2017, these kind of retro posters became very popular. So here are a couple of them. I think there's a real appreciation of this sort of yes, it's that brutalist art, I think you would call it. So here's an eclipse of an eclipse. Somebody pretty lucky to get that one. Oh, isn't that cool?
Clever.
how romantic.
There's another eclipse of an eclipse. What I really like with this one, I mean, you've got the sunspots already and the bite out of the sun, but with the jet, you also see the contrails behind diffracting the light. That's a perfect picture.
That is fantastic.
Was that from the Oregon one?
Oh,
And that might have been a chase plane.
you know what? I'd have to look.
I wonder if it's an amalgamation too simply.
Yeah.
No, that's not a cheat.
No, that's a straight shot.
That
looks
looks
like where the sunspots are. That looks like the Oregon eclipse to me.
it could be.
Yeah.
And this was from, what's it called? The Jacobs something tree park? Joshua Tree. This was the same fellow took both of those pictures, but there was a lot of planning that went into that. And
That's beautiful.
I love that one. And you see there's a little plane in the middle of the moon. Clever trick. This was a recent picture, I remember. Oh no, Moon 1000, so that was still back in 2017. And this was from in Thailand, Waterroon. I was just in Waterroon in June, so I'm very fond of this one. This one is not what you think it is.
With LED lights?
That's clever. Okay, this was the Japanese ship going around the moon, getting a picture of the eclipse on the Earth during a solar eclipse. I think that was the one that was down in Australia recently. And that was from this is the Sea of Oman, I believe, during an annular eclipse, but just as it's rising over the ocean. Boy, that's a clear day to get a picture like that.
Green flash that day.
Yeah. And this was that was the same. That was the same eclipse.
It's not fake.
That is not fake. He paid the fellow to stand there with his camel. That was very planned. Okay. Yeah, that was the space station going across. Just a little bit of an eclipse. This one I love.
Oh, look at that.
That's a time lapse of a bird if you can't figure out what it is. And I think that's the last one. That was the eclipse that also went through northern Ontario, but there it is in New York.
Randy, could you go back to the one that showed the picture from the moon, please? I have a question for you, you smart people. There, I've seen a couple of them where the shadow on the Earth doesn't look round; it looks like kind of smeared. But considering that we're looking at it from the moon, I would think that the smearing would be away from us and not sideways like it is right there. Can anybody explain that?
Middle of the Earth, wouldn't it?
Oh no, it always comes from the limit. It starts at sunrise and ends at sunset. It always goes from west to east, and it's sunrise in the west and it ends at sunset in the east.
I just assumed the sun was behind you, but it's not really.
Yeah, that's what I'm assuming.
It's over.
Well, it's a bit in quadrature there because
It's the moon's shadow creating that spot on the Earth.
Yeah. So the sun.
oh, right.
So the sun's further to the right than the camera.
I think this must be photoshopped.
You've just made me really. It's not photoshopped. I remember when it came out, there was a lot of talk about it, but okay, that's the spaceship's on the far side of the moon, but there's no reason that the eclipse has to be right dead center in the Earth. It has to start at the limb and move across.
But if it's off center, it should be smeared away from you, not sideways to you, is my point.
I don't know what you mean by your smear there.
Okay, well, you got a sharp edge on the top right there. Sorry to be going on here. And you got a fuzzy edge on the lower left, which would, that just doesn't make sense.
Oh. Okay. How much of that would be the clouds and how it's interacting? I didn't even notice that before.
You're also looking at the Earth fully lit, so you're looking at it at 1 p.m. Like there's no terminator on the Earth, so
yeah,
it should be centered. Like the moon would be high in the sky.
The sun's actually to the right, right? So
Yeah.
that's why it casts the shadow on the left side of the Earth.
It's just where the spacecraft is in orbit.
Yeah.
Yeah.
Well, the sun cannot be coming from the right because the moon is creating a shadow, so the sun has to be behind the moon, heading for the Earth.
And the moon is lit, right? So the sun.
And the moon
Well,
is
yeah,
lit.
but we're on the far side of the moon.
Yeah,
Yeah,
but the sun has to be on the left, not on the right.
No, the sun.
No,
has to
the
be on the right.
sun would be back and on my right.
To the right of the spacecraft, but.
To the right of
behind the
spacecraft,
Earth.
yeah. But behind that.
Well, a little bit off, or be directly.
Gary, good question.
well, thank you.
Okay, anyway.
My first one ever.
Is that it? think that's it. Yes. I'm done.
Thanks, Randy.
While we're on the topic of the eclipse, could I show something?
Of course.
Okay, I'm gonna share my screen. And the first thing I should do.
Apologize about the weather.
Well, this is the theme, okay, so here I was, on Saturday morning. And this is a predicted cloud forecast that, this is at 6 a.m. And the next one is at 7 a.m. And if you can see Vancouver Island here, I'll see if I can blow this up a bit.
Looks like Cal Point's clear.
I think it's
Yeah.
behind the cloud.
Yeah, so if I go down here, another one, there's the next one, you can see a little bit of clearing around Vancouver Island. This is what was predicted about 15 hours beforehand. And you can see something moving through, and the actual height of the eclipse was around 9 o'clock or 16 Zulu. And I was situated in the eastern tip of Oak Bay, and we have beautiful skies for it there. And then I saw the pictures from the hill that David Lee shared, and I was so afraid I fled to the lower mainland for safety purposes. Well, I missed Astro Cafe last week, but that shows what it was. So then I said, wouldn't it be interesting to go and get the pictures, and then I'd see the actual visual pictures and see how it looked. And this is what I came up with. What happened here? Okay, here we are. Sorry, folks.
Back at the mainland.
Okay, so these shots were taken from the Goes West satellite every 5 minutes or so. And I'm just going to have a picture here, go through it. And it's going to loop 3 times. And right now at 14Z, that is 7 a.m. The sun hasn't quite risen yet, and you're going to see it brighten up on the right-hand side of your picture as it rises. So you can see things coming up, and lower Vancouver Island is here. And
and the darkening was the
yeah. So let's watch again. This will loop through again, and so I was prevented from verifying the cloud forecast by the eclipse itself. It darkened over the sky. So it was like somebody altered the sun's light bulb and it got too dark, and the camera was set up that it could not process that picture properly. So it darkened it out. So we actually had a photograph of the eclipse from West satellite. So that's that one.
Very cool.
And there's one other thing I wanted to show you was.
You've seen that one already, Reg.
Almost like bragging, isn't it?
This is bad form. Okay, so James DeFrancesco shared a link. And darn it, I don't know if you can see it here, but this address here is to the DAO current weather shot, and they have a thing called the DAO sky camera, and I use this quite often, and it has 24 hours of imagery that you can catch. It starts around 9 in the morning and goes through 24 hours, and I find this really handy to have. If you're doing any imaging, you can go and store this particular image to your hard drive and run through it. So that's what I'm going to attempt to do. Let's see here. I'll go. I've got this recording here. Oh, that's the wrong one. I think I made a huge mistake here. Let's see. Desktop. This is it here. This is the, gives you an idea. This is starting at about 9 o'clock in the morning. The time is up here. No, it isn't.
This looks really familiar.
So this wasn't the
Too
eclipse.
familiar.
I just wanted to give you an idea of the value of this thing. That's the sun going across up at the DAO, and later on in the period, it gets dark. And on this night, the stars came out.
Oh,
and you can
hello.
see them. So you can see the stars. Polaris is up here, and this is Vega, and this is Deneb, and so we have Cygnus here. Altair, I think is a bit. I've got to move this out of the way. Altair, I think, is here, and that's the moon. So we'll just play that through, and you can actually see the Milky Way in this as well. And what's happening, if you're taking pictures and cloud comes in, you're not really sure of it, it's kind of good to assess what's going on. So I think I don't think I ran it through the whole thing, but that is a really valuable resource that we have, thanks to James DiFrancesco sharing that link with us, and it's freely available to anybody to go down there. So I
Reg, can you pick any day you want?
No, this is they're only archiving 24 hours for you.
Oh, so you have to catch it in time.
So let's say you've got some really good shots overnight, but maybe a bit of high cloud came in and you didn't know the extent of it. Then you can go to this site the next morning
and grab it.
Play that, and I screen capture it, and then you have a record to assess the quality of your image. And if you're doing photometry or something like that, it might be helpful as well. So
actually, you might be able to grab it automatically. Actually, I'll have to have a look at the interface.
Yeah, probably David. If anybody can figure it out, you can.
So is that camera right on the top of the dome?
No, that is sitting in the administration building, near the administration building parking lot. Sometimes, like I've played around with this a lot this summer, you can actually see the dome of the 72-inch open, and it rotates back and forth. It's really neat. So I've had a lot of fun with that. So the link should be there on the top of the screen if we play this back in a few weeks' time. But it's a great resource for us.
Randy, if there's time, I'd like to respond to Jeff's question from last week about sunspot groups.
It's Brock's.
Yeah, I think there is.
Oh, is there anybody else that wants to say anything, or?
I was just going to comment on the dome. People probably know that the last month or so, the dome was had a little bit of a flare at the one of the Vox Humana, the first Vox Humana concert. We had a little bit of a flare happening inside the dome. That was an electrical spark, and the dome was not moved for the entire time since Vox Humana. But they have replaced the cable inside now, and now they're waiting for a new wheel. There's one wheel that is causing some difficulty in the movement of the dome, and they're waiting. It has to be fully done by one of the manufacturers here and somebody else, I believe, in Vancouver, and they're still trying to get all of that figured out. So they have done a little bit of some work. They've been able to move it a little bit, and some research has started back up again, but they were pretty well down for like over a month because of this. So they're happy to have a few things back up again.
When Dan Posey was running it, and I was up there, which was, I don't know, it was in the summer, I guess. every once in a while, it did such a big clunk that Dan ran into the dome to take a look at it.
There's been a wheel that hasn't been working for quite a while. They've known about it. And now, I mean, now with this spark and everything, they just shut the thing down and said, okay, you know, needs some work. So yeah. But it's really too bad. Like, because every time something happens like that, the research just simply like stops. So it's a problem for them.
Thanks, Lauri. Were you going to say something, David? Or?
Yes, I'm just gonna, this is a response to Jeff's question about sunspot groups from last week.
And what was the question?
I will get to that in a second. So the question was, what is the nature of sunspot groups? So, so Brock, I hope you don't mind. I picked your photo here. This is from when we were kind of clouded out, but you captured these two sunspots here quite nicely. So one thing to note about this, the rotation of the sun isn't the way you think it is. Like, for instance, here, you'll notice that these sunspot groups follow along latitudes. So this is the pole of rotation right here. And the sunspots typically run along parallels. There's the equator. Now, the question you asked, Jeff, was you asked me why they look like this. And it's because of the magnetic field. When energy pushes out of the surface, out of the photosphere, it's done through these magnetic fields. And there you see, remember I mentioned something about it being kind of like a pole magnet. Well, here you see the north-south thing. So the magnetic fields actually travel through on the surface like that. So that's why they're like that. And groups actually are a little bit more complex than that. There may be a number of spots which have this kind of looping action. So that's basically what it is.
Thanks, David.
Okay, you're welcome.
I have a question for David, please.
Sure.
So I've often wondered when it comes to these loops on the sun, is it the material itself that's coming up and creating the magnetic fields, or are they're following a magnetic field created by some other process? Do you know the answer?
Yeah, I believe the magnetic field is created by the core, like the core of the sun, and then it bursts through this kind of molten area through the photosphere.
Okay, thanks.
David,
Yes.
Just to follow up on that answer, the question also had to do with the appearance of the sunspot in that they were one of them was elongated, as I remember, and quite a bit stretched. But you're showing multiple lines. So can you just show that slide again?
Yeah, I'm trying to see. Yeah, let me go back to it, and I'll try to explain this. There's different types of sunspots as well. The simplest form of a sunspot, if you didn't have this guy here, the simplest form would be a umbra and then a penumbra. Okay, and these all actually start off even simpler than that. There are these things called pores, which are just like a little fleck or a little spot, and they may eventually become singular like this. They'll be an umbra, and then it'll develop this penumbra. And then what will happen is sometimes a series of these will develop because of the magnetic field, and you'll have a string of them. Typically, there's two of them, so they call it a leader and a follower. But sometimes even those will start to split up, and you'll get like a chain. Now, I don't know if I can zoom in on this one that Brock has. Let's zoom in here. Oops. No, I can't. Oh, there it is. Yeah, I can't really zoom in on it. If I had prepared this, I didn't really prepare this, but This one here, that's really close to the eclipsing line, that one was actually a trail. It was a line of sunspots. So there's actually more than two. So these things are probably a complex situation of magnetic fields, which are overlapping each other. Likely, that's what it is.
Thank you.
Okay. Yeah, it's actually quite fascinating. I just took this course from the AAVSO when we started learning how to sort of classify these spots. And the reason for doing that is the solar maximums and minimums are actually based on people actually looking at the sun whenever they can and counting the sunspots. So I actually learned when to count and when not to count, because some things like pores, which are not true sunspots with the umbra and the penumbra, you don't necessarily count. So, and then when you count these, when the umbra is split, there's a different way of counting as well. So anyways, the whole thing ends up being counting groups of sunspots and then counting individual spots. And it produces this number called a Wolf number. And that's actually what is recorded over time. So over time, you'll see these Wolf numbers being recorded, and that determines when we have a minimum and a maximum, because it's not exact. Like we've got this 11-year cycle, but it's not exact.
Okay. Thanks, David.
Okay.
Yeah.
Well, I think that's everybody that had something to speak of.
Brock, before we go, I've got a question for people. I attempted in pristine skies of Oak Bay to take a photo of the eclipse with my cell phone, and it was useless. And then I saw John McDonald took this beautiful picture that he got the detail with his cell phone. And in his case, they have some high cloud that attenuated the light. And I just wondered if anybody thought to take the filter from your eyeglass, solar glasses, and put it in front of the small lens for the cell phone and take a photo that way. Did anybody try that?
I think it's a common technique, Reg. I mean, it's not going to harm anything. It might harm your sensor, but I go back to the purpose use of these filters. Because you're not actually dealing with an optical system where you're looking through the phone, it's okay. The only thing it could harm is your phone. But because the spot of the sun is so small on the sensor, likely not to do anything dramatically bad.
But David, my thing is that we had all of these lovely sets of solar glasses, and the filter on the solar glass is quite small, but it's large enough that it will cover the camera lenses on a cell phone.
Yep. There's John's shot right there.
Yeah.
Yes, but
this is done through cloud diffusion.
He used a cloud filter.
Yeah, exactly.
I'm just thinking what we could repurpose our solar glasses and put them in front of the lens of a cell phone and get some pretty good pictures. So something to think about for the people who are going to the eclipse next year. So.
Reg, that's what people on the hill, like the visitors on the hill, were doing. They were doing exactly that, and they were doing it at the beginning of the eclipse. We were using the solar glasses, so they just took their solar glasses off, put it in front of their cell phone. And
the only thing I worry about is it works for a cell phone. It actually doesn't work for other cameras. And rather than trying to explain, you could do it with this one, you can't do it with that one, I would just typically say, well, purpose built. Use the filter that is for the purpose that it was intended to use. That's typically what people say to avoid this issue of, well, okay, in these circumstances, it doesn't matter. But I'll give you a for instance. Older cameras, like digital SLRs, actually use a mirror to deflect some of the light into an optical system that you actually view. Well, that's super bad, because actually that's going into your eyeball. It's not just going into the camera sensor. Modern cameras, like mirrorless cameras, it doesn't matter. Or a cell phone, doesn't matter, because it never produces an optical feed into your eyeball. It actually goes onto a screen. You're like looking at a TV, basically.
So Margie, it sounds like some people on the Hill that did experience some success with that technique.
But I don't think it works in all cases, because I tried that with my cell phone. And it just, my cell phone just got all mixed up. It was all blurry.
Oh,
So I just said to hell with it.
Unless you have an application on the phone that allows you to control the exposure, it will get confused. That's why they don't really recommend it, because you won't come out right unless you have an app that's controllable, that can be basically set manually.
Yeah. So the only pictures I got were, you know, like John's using the cloud filter.
Mm-hmm. And actually, Nathan did some remarkable pictures just through his telescope that was filtered, obviously, right? But he just used the afocal technique that he always uses. So he's just pointing his camera into the eyepiece of a filtered telescope.
Okay. Well, thanks for everybody. Lots of good discussion tonight.
Thanks,
Yeah.
Brock.
Thank you, Brock.
When are we not coming here? Is that next week?
No,
Oh.
we've got 2 more weeks, I think. It's Remembrance Day, so it's after the 11th.
Okay.
Okay. Good. We'll see you next week.
Right.
Good night, everybody.
Bye, everybody. Welcome, Patrick, and any other new people that are there.
Yes.
Yep.